Hi students, it's Mrs. Kane and I'm back with your second e-learning lesson. Our topic today is going to be modeling exponential growth and decay functions. So yesterday we talked about graphing, now we're going to talk about writing exponential growth and decay equations and then using them to answer some real-world questions. So the first problem we're going to talk about, it says suppose your parents take out a loan of $12,000 to help pay for your older sister's college tuition. The lending company charges 8% annual interest on the loan. Use the table below to answer the questions that follow. So first, just to make sure you understand the table, we have the number of years since the loan and the amount of money that the parents own in dollars. So notice year 0 is the initial amount of the loan. So your parents are going to owe $12,000. And then each year, because the loan company is charging 8% interest, that's going to make the amount that your parents own go up by 8%. Okay, so notice that as the year increases, the total amount that your parents owe is also going to increase. And when something increases or decreases by a percent, that models exponential growth if it increases, and if something decreases by a percent, that's going to be an exponential decay. Okay, so we're going to use this table to answer some questions. The first one is to get the next y value in the pattern, multiply the previous term by what number? So the question is, what can we multiply each of these numbers by to go directly to the next number? Okay, so we're starting with a $12,000 loan and the company's charging 8% interest. So each year the amount needs to increase by 8%. So what many students often do to find the new amount after each year's, we start the initial amount, $12,000, and then we multiply by 0.08. So we know how to find 8% of 12,000. You multiply 12,000 by 8% in decimal form, which is 0.08. And so if we take this approach, we get $960. And then we have to add the $960 to the 12,000. So we actually have to do this in 2 steps. So an easier way to do this problem, a little bit more efficient, is instead of multiplying 12,000 by 0.08 and finding 8%, watch what happens if we multiply by 1.08. Okay, so if we multiply instead 12,000 times 1.08, notice that takes us directly to the answer, 12,960. Okay, and the reason is that this 1 that we put in there is including the original amount of the loan. It's including the $12,000, and then it's adding in an additional 8%. So instead of multiplying 12,000 by 8%, we're really multiplying 12,000 by 108%. Okay, so the reason that we're multiplying by 108% is because each year the amount is going to increase by 8%. So the following year, the loan amount is going to be 108% of what it was the year before. Okay, so we call this number 1.08 a multiplier. Okay, so to get from one year to the next, we just keep on multiplying by 1.08. Oh, we already did that one. So notice if I just do one more, and you can verify if you want, but we just keep on multiplying by 0.08. Okay, there's our, oops, I must have missed a number, sorry. So we're at 12,960. If we multiply that by 1.08 again, okay, there's our 13,997. Multiply by 0.08, keep putting 0.08. Multiply by 1.08 again. There's your 15,117. And multiply that by 1.08, and you get the final, after 4 years, 16,326. Okay, and notice if we keep multiplying, we can keep figuring out the predicted value of the loan. Okay, so we call that the multiplier. So to get the next y value, the most direct way to do that is to just multiply the previous term by 1.08. Again, I encourage you to think of it as the next year, the value of the loan will be 108% of what it was the year before. Okay, the next question. Write an equation in the form y equals a times b to the x. That's an exponential model to model the situation. Okay, so in our exponential equation. We're going to start by writing y equals. The A value is the initial amount of the loan. So we started with $12,000. And then notice we kept multiplying by 1.08. Okay, and when we have repeated multiplication, we can use an exponent. Okay, so we're going to put x up here as our exponent. Okay, and if you were to use this, we have to make sure we specify that the x represents the number of years since the loan. Okay, so x is really representing the number of years. Okay, so the next question, use your model to predict the amount of money your parents will owe in 8 years. So now x is the number of years, so x equals 8. So we're going to go ahead and use our model from part B, y equals 12,000 times 1.08 to the 8th power. Okay, and then we're going to use our calculator, 12,000 times 1.08 to the 8th. Okay, all the numbers in the table are rounded to the nearest whole number, so I'm going to go ahead and round my answer to the nearest whole number. Make some room so we get money. Okay, we're going to go ahead and write $22,211. So after 8 years, that $12,000 has increased to $22,211. And this is assuming that no payments were made. So this is why it's really important to start paying back loans as soon as possible. Okay, if that made good sense to you, you can go ahead and try the next one on your own. The next one, though, we will do it together. It is an exponential decay model. So very similar, but how do we handle it if the amount is decreasing? So it says the enrollment at a local high school is predicted to decrease at a rate of 1% each year over the next decade. At the start of the 2018 school year, the enrollment was 2,800 students. So if we look at the table, we have the number of years since 2018. That's your x value. Okay, and then the y value is the number of students. Okay, and it tells us that the amount is decreasing at a rate of 1% each year. Okay, so again, we could do 2,800 times 0.01, and then we'd have to subtract that amount from the original population, so that gives us 28. Okay, and then if we do 2,800 minus 28, we get that 2,772. An easier way to do it in one step, okay? Think about the population the following year. Okay, if it's decreasing by 1%, each year the population will be 99% of what it was the year before. So if instead I do 2,800 times 0.99, okay, that should take me directly to the answer. Okay, and that prevents you from having to multiply and then subtract. Okay, and notice there's your 2,772. So each year the population is 99% of the previous year. So that's why our multiplier is 0.99. Okay, so multiply by 0.99 repeatedly. That's called the multiplier. Okay, that's the most efficient way to find that decay. Okay, so to get the next y value in the pattern, multiply the previous term by 0.99. So if we want to write an exponential decay model, okay, similar to the growth, we're going to start with the initial amount, which in this case was 2,800 students. And then what's the base of the exponent? What did we repeatedly multiply by? 0.99. And then we're going to raise that to the x power. Okay, we do have to make a note here that x equals the number of years since 2018. Okay, it's not just the number of years, it's the number of years since 2018, and again, that is indicated on the table. Okay, so let's go ahead and use our equation to answer a follow-up question. Okay, predict the enrollment of the school in 2025. So the x value is going to be 2025 minus 2018. That tells us the number of years since 2018, and so x equals 7. So we're going to do y equals 2,800 times 0.99 to the 7th power. Forgot my multiplication. Times 0.99 to the 7th power. And so we get 2,610 students. Okay, and notice that we rounded that number up. All right, so what we found, we're going to go ahead and summarize what we just found. So if you have exponential growth, okay, this is the equation that we're going to use. Y equals a times 1 plus r to the t. And if it's decay, then we're going to do this a very similar equation, but instead of 1 plus r, we're going to use 1 minus r. Okay, so A is the initial amount of the loan or the population or whatever it is that is growing or decaying exponentially. Okay, R is the percent change, and make sure you change that to a decimal. Okay, as decimal. So you got to take your percent and divide by 100. Okay, and then T is the time. Okay, just be specific if it's a time period that is based on a starting time. Okay, so the next problem, it says, suppose your parents bought your house in the year 2009 for $325,000. The value of the house has appreciated by 3.5% each year since the purchase. How much is the house worth today in 2020? Okay, so the word appreciated in terms of investments or values means it's going up. Okay, so this is an example of exponential growth. Okay, so if we kind of look up here, we're going to be using the growth model. So y equals, the starting value is 325,000. Okay, and then we're going to multiply that by 1 plus, we have to change 3.5% to decimal form. So if we divide by 100, we get 0.035. So 1 plus 0.035. And then for the time, okay, the time is going to be 2020 minus 2009. So we know the value in 2009. We want to know the value 11 years later. So your exponent is 11. Okay, and then we can go ahead and put that directly in the calculator. Okay, so the value in 11 years is predicted to be 474,490. We'll just round that to the nearest whole number. It doesn't say. So I'm going to say $474,490. Okay, so that's an example of writing and using an exponential growth model. Okay, the next problem. It says, suppose your parents bought $2,000 worth of stocks in 2015. The value of the stocks has been decreasing by 10% each year. What will their stock be worth in 2021? Round to the nearest cent. Okay, so this is going to be exponential decay because the value of the stock is decreasing. So we're going to start by writing y equals 2,000. And then we're going to do 1 minus 0.10. And then for the t value, we know the value in 2015. We're trying to find the value 6 years later. Okay, so 1 minus 0.10, you could also just do 2,000 times 0.9 to the 6th. Okay, or you could just type it in exactly as it appears in your calculator. 1 minus 0.1. Okay, that's going to get raised to the 6th power. Okay, so that $2,000 stock, it says to round to the nearest cent, so that means 2 decimal places. So $1,062.88. Okay, so the nearest cent means 88 cents. Okay, so we have the tens and then the single digits. Okay, so 2 decimals anytime you want the nearest cent. All right, so the last example has a little bit of a variation. You got to be careful when you read this problem. Okay, so the last example says, today in 2020, Joey's car is worth $12,500. Suppose he bought the car brand new in 2014, and its value has depreciated by 10% each year since his purchase. How much was the original value of the car? And it says to round to the nearest dollar. So what's important to understand in this problem is that when you write your equation, the initial amount is going to determine how you handle your t value. Okay, so we're always going to start with that initial amount. So we're going to write y equals 12,500. Okay, and it says that the value of the car has depreciated by 10% each year. So you got to be consistent there. The value's going down. We're going to do 1 minus 0.10. Okay, and here's where the little variation is. So we know the value in 2020, and we want to find the value in 2014. Okay, so you're actually trying to find a value from a year's past. Okay, so you're going to do 2014 minus 2020. So you're actually going to be having a negative t value. Okay, so the exponent is -6 because we're trying to find the value 6 years ago. Okay, and again, that's because we know the value in 2020. We're looking for the value in 2014. In the previous problems, we were looking for a future value. Okay, now we're looking for a value in the past. Okay, so if we go ahead and type this in, notice I did not change that depreciation to appreciation, change the minus to a 10. I'm just going to write the equation as depreciation, and then I'm going to make my exponent negative. Okay, and what you'll notice, and it says to round to the nearest dollar, you'll notice that the amount we get, even though we wrote a depreciation problem, our amount is higher. Okay, and that's what we should expect because the car was worth more when it was brand new, so that negative exponent is taking care of that. Okay, so those are some examples of how to write a basic exponential growth and decay model and then use them to answer some follow-up questions. Tomorrow we'll start talking about something called the compound interest formula. So when you've completed the notes, go ahead and do the short assignment and submit that via Schoology. Thanks a lot.